This one is going to take a look at the coefficient of determination. Really, we're going to try to answer this essential question of how can I decide if the model I picked is truly the best one? How do we know that the line is a better fit than the quadratic? Because some of those scatter plots we looked at last time, it really could be a quadratic, it could be exponential. How do we know? So the coefficient of determination, which is represented by r squared, is actually going to quantify the strength of the model or the equation that we picked, because all common regression models actually include the r squared, because it's really going to tell us how good a fit we have. Obviously, the higher the number, the better. The challenge is not all regression types, so the lines, the quadratics, the exponentials we did last time, they don't all actually give us the R value, because unfortunately, the R only measures the strength for the linear relationship. It really doesn't measure anything else. So that's why we need R squared. So here's the good news. The closer R squared is to 0, obviously the poorer the fit, so the worse it actually is. And I think you can see where this is going. The closer it is to 1, the better it actually will fit. We're going to go ahead and take a look at this first example. Go ahead and enter all of that data into your graphing calculator. As a quick reminder, you're going to hit the Stat button, and then you're going to hit Edit, and go ahead and fill in your table. Hopefully it looks something like this. Now we're ready to find the regression model. Yes, if you would still like to take a closer look at that picture, I can kind of refresh how to do that. We did second and y equals to get to our stat plot. I'm going to tap on option 1. I'm going to make sure it's turned on. That's really the only thing you have to do. Everything else should already be where it needs to. Go ahead and tap on the zoom button and choose option 9. All right, so that is currently what our picture looks like. So what we are going to do is find all 3 types, and we're going to compare this r squared to help us decide which one is actually the best. So hit to Stat, go over to Calculate, and let's choose option 4, Linear Regression. So line 1, line 2, yes. If you'd like to store it like we did the last time, you can hit Alpha, and then the trace option, option 1. Just be sure you always hit Calculate. All right, so I've got an A value, a B value. Oh, my R squared, 0.3579. So I'm going to fill all of that in. 0.35, you can see I rounded up to 8 instead of 7, 9. And for A and B, I plugged in. So A was 1.53, B was 35.69, or you can even say 35.7, however you would like to round. Okay, that R squared's pretty small, which kind of makes sense because you can see that line does not fit that data. So that's a good indicator your R squared should be low. So let's try the next option, which was quadratic. So that's going to be option number 5. Still list 1, still list 2. Go ahead and alpha and trace if you would like to store the equation so you don't have to copy and paste. Always hit Calculate. Well, would you look at that? 1, those are beautiful numbers, but take a really close look at the R squared. You'll see that I did use a hat on top because, again, these models are predictions. Sometimes they're a perfect fit, sometimes they're not. But yes, the R squared was 1. We're not used to the ones being so nice. I'm going to hit the graph button, and clearly that is a perfect fit, which is why your R squared is equal to 1. It is a perfect fit, is the best option. But you never know. Let's go ahead and check the last one, which says exponential, just to be sure. So I'm going to hit the Stat button, go over to Calculate. We're going to choose exponential, which on your calculator should be option 0. Same thing, list 1 and list 2, x's and y's. I'm going to go ahead and store this again in y1. I'm just going to keep replacing it. Ooh, okay, R squared is 0.2069. What does this even look like? Well, that's just terrible. Look how far away all those points are. So again, there's my hat, and you can see I wrote it as an exponential, and yeah, 0.207. So I think you can see which one is the worst and which one is the best. So your quadratic for sure is going to be the best fit because our coefficient of determination, or the r squared, is equal to 1. So now it says use that regression equation and determine what the value for y is whenever we have x is equal to 27. So all we're going to do is take our equation and we are going to plug in 27. So once you go ahead and plug in 27, you should get somewhere around 37.8. So that's kind of how we can use data, fit a model, and then make more predictions that we don't already have in our table. All right, same thing here. Let's enter this new list into our graphing calculator. Okay, so here's what your list should look like. Again, that was stat edit. Let's go ahead and figure out if the line, the quadratic, or the exponential is the best fit. So stat, go over to calculate, option 4 for lines. Again, if you would like to store it, just so you can actually see how close it is to your points. Ooh, we have r squared is equal to 1. Well, so far it looks like my line is winning. So we're going to go ahead and fill in those values for a and b. Okay, let's try the quadratic. Here's where it's going to get a little weird. So stat, over to calculate, option 5, the quadratic model. So we're going to store again. I'm going to replace it with y1. Wait a minute. R squared is 1 again. How can both be a good fit? Look really carefully at a. Notice that a would be 0. So that x squared piece is pretty much gone. So all this gave you was basically the exact same thing as the linear. It just had 0x squared. So this is kind of what it was doing instead. Well, that's the exact same thing as the linear model. So that one's a little goofy. All right, let's go ahead and check the exponential. This is our last option. Maybe this one will be even better. Who knows? If you don't remember, your exponential is option 0. Again, feel free to store this equation. So if you want to see what it looks like, always hit calculate though. All right, ooh, r squared is 0.99779. I'm going to hit the graph. So you can see it's pretty close, but I still have a few points a little above and a little bit below. So yes, your exponential is really, really close, but you can see that the line is still the best fit because the r squared is equal to 1. It's almost exponential, but this is how we can decide which one is actually better, is that r squared value. All right, so on this one, we are trying to determine the optimal time for us to pop our popcorn to get the most delicious kernels, and obviously we don't want it to burn. So we popped different bags and counted the number of kernels, the good popcorn. So I've got time and I've got number of popcorn. Well, let's go ahead and first see what this looks like. So we're gonna do the same thing. We're gonna hit stat and edit, and we're gonna go ahead and enter in all of this information in our graphing calculator. All right, and here's what your list should look like. Let's go ahead and I'm going to clear out our old stuff, and I'm going to tap on zoom 9 so I can get a really clear picture, because sometimes your picture really can save you time in trying to pick the best one. So here's kind of what our graph looks like. So I've got time is on my x-axis, number of popcorn is on my y. Which model do you think we would probably try to fit to this one? All right, let's go ahead and try out quadratic. It looks like a quadratic, so I feel like this one's going to be the best one. Again, I'm going to go ahead and store this equation into my graphing calculator. I'm always going to hit calculate. Okay, r squared is 0.817. That's pretty high. It's not terrible. And I've got my A's, B's, and C's. So what we are going to do is go ahead and use a nice quadratic. You'll see that I used my little hat again because it's predicting the number of popcorn. And again, our r squared is pretty close to 1. It's at 0.817, which is really nice. If you would like, you can hit your graph. And again, you can see it's not the greatest fit, but it's not the worst one. So you can see our quadratic is missing a few points. It's definitely close, but this is the best quadratic that's going to fit inside. So on here, we're having to explain why would a quadratic make sense for this situation. So again, here's my time versus my popcorn. And take a careful look at the background information. Really think about why a quadratic would be the best fit. So on here, really we can think about it like this. As our time increases, the longer I keep the popcorn in the microwave, obviously the number of popcorn is going to increase. I'm going to get more and more popcorn. Ooh, but eventually if I leave it in there too long, it's going to burn. So I'm not going to have really, really great numbers. So I can see here, the longer I leave it in, the better my popcorn gets. Oh, but here it starts to drop again because I'm going to be burning the popcorn. So that kind of makes sense why this one would be quadratic. This wants to know what is the optimal time for popping our corn. So basically, I want the most amount of popcorn. I want the best time. Okay, now how would I find this on the graph? So really, we're just taking a closer look at the maximum of this graph. So anytime you see the word optimal, you're really looking for the best time for us to pop our popcorn. So here we can do this by hitting the second button and then the trace, and then choose maximum, option number 4. So again, your calculator will say left bound as it's asking you a question. So as long as you have that blinking light on the left side, you're good to go. So I'm going to hit enter. Now it'll ask you another question. It'll say right bound or right side. So I'm going to go all the way to somewhere on the right side. So now it's saying look for the maximum somewhere between here and here in this region. No guessing. So go ahead and hit enter again. So I can see that the maximum or the optimal time for my popcorn is around 104.37 seconds. And I can even see the amount of popcorn that I would get. And you can see on here, I kind of changed it to about 1 minute and 45 seconds. And this might be for maybe a smaller bag of popcorn. It might not be for one of the big ones. But again, this is a prediction because you can see how far away our curve is for the popcorn. So kind of something to keep in mind when we start making predictions with graphs is sometimes we're kind of off by a little bit. If you take AP Stat, you'll actually learn what that's called when we make a prediction and we're still off by the actual amount. All right, let's take a closer look at example 4. Here we have an object is at a temperature of 160 degrees Celsius when we're removing it from a furnace. So this could be pottery, this could be something artistic like clay. And then we're putting it in a room that's about 20 degrees Celsius. We kind of saw this one with Mrs. Hawkins' pot of coffee in one of our practice exercises. Well, same thing. Let's go ahead and stat, edit, and get this into our graphing calculator. All right, let's get a clear picture. How do we know what this even looks like? Because it would take forever to just start plugging in random models. So I'm going to tap on Zoom, option 9. Okay, it kind of looks like it's dropping. It kind of starts and slowly kind of drops down and starts decreasing. So now we can start eliminating some options. So obviously it doesn't look like a line, so I'm not going to choose that one. I mean, maybe it's a quadratic. It could be just like a piece of the quadratic. I could see it maybe like dropping down and coming back up. So let's see what a quadratic would do. So stat, calculate, option 5, quadratic. And I'm going to go ahead and tap on calculate. That r squared is huge. It's 0.9649 and a couple extra digits. That's pretty close to 1. Man, that quadratic looks really good. It looks like it's a great fit. But is it the best fit? Maybe let's try a natural log, option 9. So list 1, list 2. I'm going to store this one because I'm curious what it's going to look like with my points. I'm going to hit calculate. And would you look at that, r squared, 0.96549. So you can kind of see that our natural log is actually a better prediction. It is slightly higher. So on this one, our natural log is going to be the best fit. So we can plug in degrees and we can get our time. And then again, that r squared was 0.965, which was very close to 1. It was slightly better than our quadratic. So now we just want to know, we can use this model and make a prediction about how long it would take for an object to cool to 50 degrees. So I'm going to go ahead and plug in my 50 degrees and get somewhere around 2.632 hours. If you stored that equation in your calculator, you can actually hit your second and trace, remember our happy place. You can choose option 1 and actually plug in 50 degrees. And there's your time, so 2.632 hours. So that's a really nice shortcut to help you plug in a little faster, especially because you have all these extra decimals. So you can see your graphing calculator actually includes more decimals than we possibly could put on our paper. So we are planting a sunflower in our garden. We have the height of the flowers in centimeters after a seedling has been planted after a certain amount of weeks. This model we've never seen before. It's actually called a logistic function. It almost looks like our rational function mixed with our exponentials. It's like those two got together and created a whole new function called the logistic one. So on this one, let's go ahead and estimate that horizontal asymptote. So it's kind of getting close. So maybe somewhere around 260-ish, maybe that. Fun fact, it's actually 256, but don't worry about it. I would estimate to be around 260. So really try to think about, what does that represent in this situation? Well, here we can see we have our sunflowers and they're growing after 0 weeks, growing. And then all of a sudden it slows down. So no matter how much I continue growing my sunflower, it doesn't keep growing to the sky like Jack the Beanstalk. It eventually kind of tapers off and slows down. So really, this is the maximum height that our flower can grow. So you can even use other types of models that we haven't seen in this class to make other predictions in real life, like sunflowers, things like that.